Hello everyone! Today we're going to talk about the mole. So, a definition of the mole is the mole is the amount of substance of a system that does contain as many elementary entities as there are atoms in 0.012 kilograms of carbon-12, which is the isotope of carbon, and its symbol is simply mole. But also, we have another one saying that mole, having the symbol mole, is the amount of substance of a specified elementary entity, which can be an atom, a molecule, either an ion, electron, or any other particle, and its magnitude is set by fixing the numerical value of the Avogadro's constant, which is exactly 6.0221429, which we round off as 6.022, times 10 to the power of 23 when it is expressed in the SI unit per mole. So obviously, 1 mole is 6.022 times 10 to the power of 23 particles, and this number is also called the Avogadro's number. Now, some main points about the mole are that chemical amounts are measured in moles, and the mole, which has a symbol mole, is the SI unit for the amount of substance that we have in a certain area or in a certain problem. And 1 mole of substance does contain the same number of the stated particles, which can either be atoms, molecules, or ions, as 1 mole of any other substance that we take into consideration. An example of that is that if we have 1 mole of sodium, or Na, then it does contain 6.022 times 10 to the power of 23 atoms of sodium. And if we have a mole of hydrogen, molecular hydrogen, then this also contains 6.022 times 10 to the power of 23 molecules of hydrogen. Or if we have 1 mole of sodium chloride, or table salt, then it does contain 6.022 times 10 to the power of 23 formula units of sodium chloride. So what we see here is that we have 1 mole of sodium, 1 mole of hydrogen, and 1 mole of sodium chloride. And we have atoms for the first one, molecules for the second one, formula units for the third one. However, what we always use in all 3 examples is the Avogadro's constant, so 6.02 or 022 times 10 to the power of 23. So no matter what particles we take into consideration, either if they are ions, atoms, or molecules or formula units, 1 mole still has to use the same Avogadro constant. More on this topic. So the mass of 1 mole of a substance is known as the molar mass. So if we have mass, for 1 mole it's molar mass, and for an element it is the same as the relative atomic mass that we write in grams. So when we look at the periodic table, we have the average atomic masses, and the relative atomic masses for each element are the same as the molar mass, since we have them being in the same state. So if we have hydrogen or oxygen, then we have the molecular hydrogen or the molecular oxygen having the molar mass double that of the relative atomic mass. That is because in nature we find these 2 elements as molecules, as diatomic molecules. For all the other elements, we find them having the same relative atomic mass as their own molar mass. And lastly, for a compound, it is the same as the relative formula mass or the relative molecular mass that we give in grams. So the molar mass is the same for relative atomic mass that we give in grams for a certain element, but it is the same as the relative formula mass or the relative molecular mass that we give in grams for a certain compound. So either if we're talking about an element or a compound, we have the molar mass being equal to another measurement that we use in our calculations or different stoichiometries. This was all for today as about the mole and what we have to know as main points regarding that topic. Thank you for your attention.